Good afternoon, ladies and gentlemen. Thank you very much for coming back in for this session. Our next speaker is Alison B. Lowndes, Senior Scientist, Global AI at NVIDIA. And what she wants to talk about, she says, is cool stuff. Cool stuff thanks to the gamers. So, Alison.
Thank you. Okay, can you hear me okay at the back? So thanks very much for the invite. I'm going to run things from here. But what I want to do to begin with is start with this, because we are in the decade that will define the future of humanity. And to quote our wonderful Sir David Attenborough, Earth is actually a closed system. Try going into space, if you don't quite understand what I mean by that. And examining it at a planetary scale is crucial. So this work by Rockström, I believe you pronounce it, and others actually shows 9 planetary boundaries. And this work is actually a few years old now. Breach any one of them and we actually destabilize Earth. We've breached 2/3. And make no mistake, nature does not care how much money you have. While it's true, if you had a helicopter, you could fly out of the Bahamas back when Hurricane Dorian hit in 2017, wealth is not going to help you, especially if you're currently oil rich. Every nation prospering from oil wealth right now is about to be hit karmically by a severe downward trend in growth unless they divest into renewables and start actually contributing to net zero, versus just trying to sell off whatever they can of their dwindling fossil fuels. Meanwhile, it's actually those that have contributed little, if anything, to global warming that will or are suffering the most. But let's hope some of the COP pledge money will actually get to them, and that more and more start to take on the essential role of planetary stewardship. So that's my teammate Shilpa on the right with Baroness Patricia Scotland, the Commonwealth's Secretary General, and also Berkeley's Solomon Darwin on the left. They're at COP28. This is work that I'm very proud to be involved in. It's helping to provide visualization, but also understanding for the many boss nations. So BOSS is big ocean sustainable states, those who will suffer the most from sea level rise. So at NVIDIA, we're able to put together solutions that provide physically accurate visualizations of, for example, how a seawall could help a coastal community, not just from sea level rise, but from devastating tsunamis, from non-predictable earthquakes or volcanic eruptions. At NVIDIA, our tools enable vast numbers of tier 1 and tier 2, and further down, service providers of all levels to take predictive capability and offer it to more and more customers. This image is actually by RSS Hydro. They are a hydrology specialist, so riverine systems. They're actually based in Luxembourg, and they use our tools to show, in this case, sea level rise, just from digital elevation models. So there's no AI here. But this is actually Tonga by the year 2150. And actually, this is just a snapshot of the 3D video that they put together, because seeing the consequences makes it much easier to push for climate resilience, to actually put in for funding of those COP pledges to get the mitigation efforts. But to see the risks up close, it's really, really essential for most people who aren't expert hydrologists. I'm also very proud of the fact that our hardware at NVIDIA is the #1 across the world, the most efficient and sustainable compute available. Our GPUs, that's graphics processing units for the non-gamers, they're actually in 7 now of the top 10 supercomputers in what's called the Green 500 list. I've put the link in the top right there. And UK has now got Isambard 3. It's actually being put together as I speak. with our Grace Hopper, so that's CPU and GPU combination. And that the Grace Hopper combination in ISAMOD 3 is actually number 2 in the world today. Because the highest capability is only acceptable at the highest sustainability. And we've ensured that our compute provides the greatest efficiency possible today. Tomorrow, well, we're constantly developing, as is the field of AI, constantly evolving, constantly improving. So let me show you a few examples. So here, partners Cesium are working with our simulation platform. They're using geospatial data from Maxar, from their satellites, to provide the US Space Force with an open USD interoperable test environment of Cape Canaveral, of the launch facilities. And this is perfectly synced with the real launch site. The market itself for reality capture is vast when you consider all required government and city planning, transport and logistics, insurers for environmental impact and risk assessment, defence, and that's both military and for climate now, telecoms, space comms, agriculture. In this case, a digital twin was actually necessary due to the increased collaboration with private industry like SpaceX, for example, to enable simulation of hazard areas, fully geo-referenced by Cesium and coupled along with aircraft transponders, so full telemetry, all unified into a visually understandable environment for all ground, land and space ops. And there's actually so much more of this work to do. We've already got the capability of what's called terraforming high fidelity road systems and cities. We had to for the virtual training of self-driving cars or autonomous vehicles, AV. This is actually a key point. We have this now, today. Once we have a fully connected network of vehicles, there will no longer be a trolley problem, which is the big safety issue. AV will be safer than humans are today, but we're only at this stage because of the metaverse, the simulated world. In fact, to reach net zero, you really need to harness the pixels, the bits and the pixels. NVIDIA started out in gaming, but gaming actually grew up and is now truly helping humanity. Virtual worlds where collaboration is effortless and companies across every industry can unlock new levels of operational efficiencies and innovation, from self-driving cars to factories to robotics to the entire Earth. Normally, I insist now on giving talks remotely over the internet, where I can travel to any place on Earth at the click of a button and show you this exact same information and speak these exact same words instantly at no cost. But I actually only live 2.5 hours away, so I'm here in person today. This is actually one of our AV fleet garages, so real world. This is mission critical AI, where human lives are obviously at stake. But it's where we're heavily investing, because this is the top of the AI mountain. Solve this problem and you've pretty much solved most of the others. Bear with me. Skipped one then. And our Earth 2 capability, which is, the planet Earth, enables us to tame some of the chaos, namely to simulate long-term, so 100-year plus climate, and therefore the shorter-term version of that, which is weather forecasting, but at kilometre scale, within a reasonable power budget as well. And what I mean by that at the moment is under 30 megawatts. But we can only do that by using artificial intelligence to emulate the physics and accelerate the compute by orders of magnitude, so tens, hundreds of thousands of times, while also serving this information to billions of people in a cloud-based digital twin platform that allows interaction, analysis, and ultimately decision-making. And we visualize, we present all this in what we call Omniverse. This is where we can combine data from various sources, or you can provide the data, where we can move from low-res to high-res, blurry to sharp, seeing clearer, but also able to achieve a much larger probability distribution. of outcomes, which means we greatly reduce the uncertainty of what could actually happen in specific regions. Our latest model, CoreDiff, which is correcting with diffusion modeling, that's the same AI that you can use to generate cool images with. But in this case, it's used for downscaling high-resolution data. So high-precision prediction from low-resolution data, which means low compute, which means rapidly computed at low cost. CoreDiff is actually available today, predicting extreme weather phenomena with unprecedented accuracy and efficiency. And that gives you the ability for response, for planning, for adaptation. But Earth 2 allows you to use many different community models, and there are many out there, not just ours. We work with all of the big tech groups and the weather forecasting agencies, because this is the goal of having fast, efficient, actionable, sustainable insights, guiding organizations and entire nations around climate risk. So Earth 2 includes model inference, or you can use our modular software to actually train the models, but reality check, training CoreDiff currently uses 2,000 to 3,000 GPU hours to actually get the results, which you're then able to infer from. That's the deployed service that you can use. But that's on Hopper generation GPUs. Our latest Blackwell will reduce that again. But inference itself is as I said, deployable. It's negligible on the compute side. And you can actually go online and test it now. You can create an AI weather forecast with just here 8 lines of code. So import, in this case, ForecastNet or FCN, the data pipe and the function. You load the model, you set it up with GFS, initial conditions. That's the global forecast system that the US's global numerical, as opposed to AI-driven weather prediction system uses today. ZAR is the file format that provides the classes and the functions for working with large dimension arrays. It chunks them, it compresses them, so that you can ultimately predict, which is the last line here, 26-hour time steps into the future, which is about 5 days or longer, depending on what you actually want it to do. Obviously, this is code, it's adjustable. FCN is one of the multiple models available in the Earth 2 Studio that's out now. The 4 part actually stands for Fourier, or you may have heard of FFT, fast Fourier transforms. So these Fourier neural operators actually use the Fourier scale as opposed to, distance, height, width, length, height, width. And that in itself, that Fourier scale, moving from Euclidean, gives you these orders of magnitude that I mentioned. This software continues to evolve, and there are multiple variants, including spherical harmonics. So basically, you can compute regardless of the actual grid that you're putting around the world, turning the world into a mathematical grid. The core operation is a simple, what's called multi-layer perceptron, hence the vast speed. And we're actually already in the 2nd year of development for the first of many of what's called Earth system models, so atmospheric for NOAA. Then we have to integrate the ocean systems, rivers, ice, population demographics, for example, all similar to Europe's Destiny project, if you've heard of that, which actually just announced that it's also now looking to deploy LLMs, so chatbots, to enable non-expert users to get further service from it. All of this will take time, and it's not just us doing it. We work with all of the big authorities and agencies. But the tools developed throughout that process are vital. These little value adds, like having lane correction, in modern cars today, things like that. That's just one tiny value add on the road to self-driving. But we also have that breakneck speed, the bleeding edge side of tech to actually, to our advantage. And to be honest, if any of you in the audience are thinking that, well, this is all, cool, but maybe a bit too sci-fi, unbelievable, this is work that we've been enabling for years now. It's a multi-year project simulating the paths of neutrons from the fusion tokamak in Surrey for the UK's Atomic Energy Authority. It's actually a collaboration with Oxford, Manchester, Vanderbilt, a few others now have joined to bring fusion much closer to commercial viability. But the design and the engineering is virtual, in our platform Omniverse. So there's no risk, but for the hope of clean power for us all. But Monte Carlo neutronics, GaN4 neutron transport, precise particle physics, but just bits and pixels. The exact physics comes from, over 20 years now of the PhysX engine. Or you can just import results from other solvers into Omniverse for visualization. Use things like the ParaView connector, for example. Or you can use Modulus for training physics-based AI and running the instance directly in Omniverse. And here's another example. Any idea what you're looking at here? Close. Very close. Could be, it could be. It does get utterly stunning, I'll give you the punchline, but it's also very, very brutal. And this is, what you're looking at is compute and obviously the visualization of a very fine scale evolution of the death of a star, a supernova. And it's computed with index in ParaView. And this is actually a few years back now. I believe Betelgeuse is somewhere in that process as I speak, but we're not quite sure where. As for down to Earth, now this jumps around a bit because it's not just a factory digital twin, but it's putting on VR headsets and haptic gloves and holding meetings in the digital twin, what's called multi-user XR or extended reality. So you can plan your logistics or your shipping or your factory in Omniverse and get in there and figure out things like ergonomics, etc. Omniverse was actually built for ray-traced VR, full fidelity photoreal rendering, and it's very, very extendable and very, very scalable. You can actually reconstruct scenes in 3D of anything and then just stream it to a browser, tablet, phone. Now, the bits themselves. We've had floating point 8 since Hopper generation, so that's over 2 years now. And it was actually a huge leap forward for society. It's a collaboration with ARM, who are talking here today as well, Intel and ourselves. But it's huge because it essentially carves the carbon footprint of AI. It halves the carbon footprint of AI. Using lower precision number formats actually improves computational efficiency, but it also reduces memory usage and it optimizes for interconnect bandwidth. That's moving around all the data among trillions and trillions of mathematical operations. Transformer networks that run all the large language models, the LLMs you hear about, the chat GPTs, they benefit in particular. And this is implemented natively in our Hopper GPUs and Blackwell, the latest too. No doubt FP4 will come along very, very soon. But English today is why AI is such a multi-billion-pound industry. Generative AI or Gen AI, including those large language models, but not just those, can perform AI for you. You just need to ask it in English, or throw in a language component and use any global language, or most of them, anyhow. They can code too, so you don't need to. Just speak or type, and the agent will actually understand and provide a reasoned response. The really cool stuff is that as we're developing this AI, we're also learning more and more about ourselves, about humans, about our own system 1, so that's the fast, and system 2, slow ways of thinking. Gen AI can already use tools like the apes did millions of years ago, except today it's not just robots chiseling, it's agents, that's artificially intelligent entities, actually using web browsers, calculators, or simulators. They can also join forces with other agents too, and with us, humans, in order to solve more and more complex problems for us. And they can do all that multimodally too. It's not just text or speech, but using images or every single video on YouTube, or physics, biology, chemistry. Think of all that information that we've all been uploading onto the internet for the past 35 years. AI can access all of that knowledge and more if you allow it. It can also access all of your company proprietary data if you allow it. So what you do is you fine-tune models to become specialized in the way that you need them to be, firewalled and safe. Firewalled and safe, assisting customers in more and more complex but concise ways. It has to be simple to use, visually, audibly. And maybe even soon we'll start to add touch, taste, smell, maybe not all human capability. I'm not sure how we're going to give them our sixth senses, etc. But who knows? Emergence, a neuroscience field, is a fascinating research prospect, and it's very active. And since we can accelerate pretty much every possible workload in every digital scenario, who knows? Doubling performance, quadrupling environmental efficiency almost every year. You can tell I'm quite a fan. But models are basically streamlined for customization, otherwise they're no use to anyone. And you can use our Nemo package for data ingest, applying security guardrails, and the very latest customization techniques to tune with our own data. This is all ran either on-prem, in your offices, or in the cloud. The highest performance efficiency is always guaranteed. And Leanne just spoke, if you saw the panel earlier, VP of ServiceNow, and we have a large strategic partnership with them for deployment, because that's what NVIDIA does. So pre-built containers, for example, can ensure and will ensure that the infrastructure, the software infrastructure, is robust, it's tested, it's validated across all of the major hardware, so that all of the major cloud providers. So software, hardware, but also all of the standards. But it's not just language models, it's vision models too. Video. We can now do video language models. It doesn't really matter, that's what I meant by the multimodal sign. And it's getting more and more complex and more capable, all adaptable to your unique requirements. So smooth, quick, seamless integration and deployment, that's basically what we spend most of our time doing. As for the hardware, it's actually quite difficult to explain the speed that we're now able to innovate with the help of artificial intelligence. We only just announced Blackwell, and already, so that's our latest silicon, already there are rumors of the next buzzing around. But Blackwell brings 25 times the energy efficiency and 4 times the performance of today's Hopper. And it's even more secure too. So, we're adding more and more for dealing with the most sensitive data without performance compromise. Now, I don't have nearly enough time to get into this, but perhaps at the end if I leave enough time. But do read this if you haven't already. That fine-tuning is how you control things like hallucination. And don't forget that hallucination, or being creative, is in itself a multi-billion-pound industry. If you need the agent to be absolutely precise, then it will answer you as precisely. So with large language models, for example, as precisely as that information that's on the internet, which is where it's getting its information, along with fine-tuning from human feedback and reinforcement learning. So it's the precision that you want or the hallucination that you want that determines what these models do, what AI will do for you. But this blog post is really interesting. Do read it. Take Mark's AI risk number 4. Will AI lead to crippling inequality? No. Because AI's core trait is to be open sourced. It's in your and our own interest to sell to as many customers as possible. That's what we do. We scale up deployment of AI. Why? Because the largest market in the world for any product is all 8 point something billion of us. AI is empowering everyone on the planet via mobile. And I know this because I actually work with Maasai in the Kenyan Masai Mara. That's just another life of mine. Technology is not responsible for inequality. Governments are. But AI will make it easier for bad people to do bad things. But it's the same with fire. It's the same with any tool. What's the solution to good versus evil? Perhaps better parenting. I'm biased, I'm a mother of 2. But how do we get there? AI making life easier so parents aren't struggling and bringing up their children isn't as stressful, where they can afford perhaps to move to safer environments. How can I stand here and possibly say that? Because I retrained at 42. I learned to code and I joined NVIDIA a few years later. I was also a single mother with 0 family support, so I know that anybody can retrain. Now, another exciting field is modernising customer service. We were doing this years ago, playing around, and you can see how gaming influences this. I should have brought the live video here, but I was putting way too many videos into this, and I only have a small amount of time. It actually starts with voice, so fully synthesized by our Reaver software, then software to drive facial animation of the avatar, and animation graphs which define and govern its movement, hands, arms, eyes, lips, even subtle movements like nodding while listening to your questions. Our open source materials language even defines the jacket so that it looks like real leather, all while the ray tracing and the rendering brings the whole avatar to life, talking to you and listening intently in high fidelity in real time. And this is all available today. If you need more information on that, even training for employees, we have hundreds of hands-on classes, including working with avatars. And the majority of our software is available for free on what we call NGC, so just go to that link and take a look around. But my domain expertise is actually up there in space. Digital twins are not confined to just systems on Earth. And right now, robotics, virtual robotics especially, is exploding in preparation for building the moon base. And that's why we have a very large capability for virtual and physical robotics. We just announced a new platform for humanoid robots too, based on our Thor hardware, and lots of new software, including Isaac Lab for robot learning and deploying robotic foundational models. Thor is actually based on our Blackwell silicon and is capable of performing just trillions of floating point operations per second, but with functional safety hardwired. Isaac Lab is accessed within Omniverse and is tailored for what's called autonomous mobile robots. So here you can train them virtually to see, to localize, to operate very robustly and safely. And then that training just ports seamlessly into the real life robot that's already able to sense and adapt to very varied environment in our human lives. You can actually pull the entire reference architecture of Carter here online. Just go to the website, including the full navigation stack, so you can start to play around with it. And you can talk to Carter too. We've been inputting instructions to Carter for a few years now, so it can answer questions and move to specified locations. We can even teach new behaviors to Carter. It's delivered popcorn in HQ in Santa Clara for years now. But remember that trillions of operations, mathematical operations, or trillions of tokens for language models are no match for human-robot interaction. So humans assisted by AI. And once we add sensors too, like cameras, for example, we can also capture here neural surface reconstruction and model the volumetric representation of entire scenes. So in training, this also helps because you can create synthetic training data, for example, for AV systems to continue to train on. So it's self-perpetuating. Point clouds to autonomy. And it's very, very simple in-world to randomize. Think spawning new characters in gaming. You die, you play again. But here, it's scenes, lighting, objects, everything can be respawned or synthesized. So AI can capture the world, and we can bring it into the virtual world and populate that world with new 3D assets. But what about movement and behavior? This character is being simulated entirely through physics. An AI controller is driving the character's arms and legs, ensuring that it stays balanced as it executes moves. And it's learned this from human sample motion, but it's also learnt it from scratch to stand up, to balance, to move its legs, to walk, to run, but also training thousands and thousands of agents all at once, competing against each other with something called multi-agent reinforcement learning. While another layer of AI is combining those multiple motions together to execute higher level tasks like run over and hit this column with your sword. And you can hopefully understand why gaming needs this, but so do industrial robots. Once trained, you control via voice or text, and all is done within Isaacs. It's only possible with GPU-accelerated PhysX, the physics engine I showed you, within Omniverse. And here you can actually see how simple and cost-effective it is to parallelize navigation training, in this case, in world. It can just go on and on, as depending on the compute that you have available. It also allows us to explore what I mentioned earlier, things like emergence, and allowing agents to learn awareness of others, even self one day perhaps. Think how many times you've used YouTube to learn something. Millions of people do, but robots can. And we can teach children anything, by showing them, by teaching them, like karate. But robots can also learn from demonstration, but also naturally from within robot communities, like we do at school. And as more and more machines get together and more humans accompany them, all working together, things will exponentially improve, because true intelligence requires awareness mentally, bodily, and environmentally, the world around you. And it is the only way that we will teach robots and AI empathy, for example. Now, imagine that kind of capability onboard satellites and onboard spacecraft. For things like Earth observation, disaster recovery, and all the hundreds of other use cases for both climate and military defence. I've actually pinched Issa's slide here because I work with them. They won't mind. And with many startups that I work with. So OSK, Orbital Sidekit, was the first that I know of to deploy our embedded GPUs, so that small form factor, sort of the size of a credit card, into their hyperspectral imagers back in 2017. It actually operated external to the ISS and did that perfectly for over 12 months. And their second and third gen are now in orbit, offering persistent monitoring. And they have many customers, government and industry, things like identifying and tracking objects with frequent visitation. So on the left, one of their images, just in RGB, so red, green, blue, is a methane leak that they've detected, but zoomed in with hyperspectral imaging on the right. And that's just one use case. We have to monitor methane emission as well as carbon dioxide. Methane is, just as devastating, even though it's shorter lived. Another use case is monitoring illegal logging. And this, again, is funded by government contracts that gives that funding to all of these startups. Illegal logging can be from illegal fires or natural wildfires, which are also springing up now, all crucial to our survival. So to recap, Omniverse is our platform for building and operating metaverse applications. So today's internet connects websites, 2D pages with HTML, viewable on a browser. Omniverse extends this to 3D. So you're connecting virtual 3D worlds viewed through browsers or even VR. But you're also, it brings together all of the rendering capability that we're known for, and all the physics capability through the PhysX engine, multi-decades of that, all of the entirety of the AI field, all the magic. Of course, computed with our GPU acceleration, with our hardware, but most importantly, it's synced to our real world, to our sensors, satellites, cameras, CCTV, to our controllers, and to us, society. There is a ton more, big learning curve for Omniverse. It is an entire world, so here are some resources, and hopefully you can dive in further offline. And please do try Gen AI today if you haven't. Speak to ServiceNow for any number of applications relevant to you. You can actually just go online and test as well. But the world is getting much less complex. Even the traveling salesman problem is solved. So our QOP software is world record fast. Commercially, TSP, it's all about vehicle routing and scheduling, so last mile delivery. But it's still factorial complexity. But when you combine that with evolutionary or genetic algorithms, it's now deployable. It's solvable across entire fields of operations, and think any kind of logistics. Domino's Pizza, for example, they already use it. So just choose it from our API catalog online, try it for free, deploy it if you want to become more efficient and save some money. There are opportunities at every scale, and I urge you to join the new era of 3D design and simulation as well as artificial intelligence. But these are environments that have to be and are indistinguishable from reality, except there's no risk and much less cost. So finally, how is any of this possible? What do we mean, the hardware? This is actually Hopper. We put 8 together on a sled, all linked across NVLink switches, all acting as one big GPU. That goes into a server with the central processing units, with the memory. But crucially, it's racked in what's called computing fabric, so the most vital part of any AI supercomputer, with all of the latest networking that we have available today, and scaled up to however big you actually need it, however many nodes that you might need, or in whatever configuration that you need for all the hundreds of different workloads there are, and we work across all of them. And we know that you need to use every watt and every square meter you have in that data center. So MGX, or modular graphics acceleration, standardization for time to market and an improved return on investment, whether it's for running Omniverse or focused on graphics or even generative AI. Even liquid-cooled, for even more sustainability. So if you only do one thing after this talk, please sign up to what we call DevZone, so that we can keep you informed of this breakneck speed, this bleeding-edge tech that we're doing and bringing in, but also to give you access to what I've just shown you. And thank you very much for listening.
That was absolutely fascinating. Sadly, we don't have time for any questions, but there is one I want to ask, which is, in the history of evolution, no species has ever introduced a smarter version of itself into the environment. Are we wise?
I think we're wise because there is a huge amount of...
Hang on.
Thank you. Are we on?
Yeah.
We are wise because there is a massive, massive research field that doesn't get the news and doesn't get into the movies on safety and on the human, computer or human robot interaction side. We know a great deal, and as I mentioned, in that huge amount of info I just downloaded on you all, there's a lot being done and also a lot being learned about ourselves while we're in this, AI revolution. So yeah, we are wise. I've got a lot of hope because I know the ins and outs. There's also a lot of hype out there. Movies are great for a reason. The latest one, I'm not even going to get into it. But yeah, we are wise because we know what we're doing, and as we learn and as we evolve, there is always somebody out there in the 8-point-something billion of us that will say, what if this happens? And we run back and, and we can do something about it. And I'm also very, very hopeful about how it can help us, as hopefully you've just seen, I've just shown you, to deal with the other stuff that we're not doing very well about, which is looking after our environment and dealing with the climate risk that everybody has now, regardless whether you're techie or not.
Good to hear. Listen, thank you very much again. Thank you.